Hello friends, this is Durga again from ITversity, a one-stop shop to learn all the technologies. So as you guys know, this is backup for the live training. And if you want to practice whatever I'm streaming in these videos, you can use labs.itversity.com. And you might have already known the plans we have. It is $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. That being said, let me start the session in WebEx, and then we will take it from there. So I'm back, and I'm making myself as presenter now, and I'm sharing my screen. So we are in the middle of Hive. It's about Hive QL, and yesterday I was talking about just give me a minute. Where is that query? Yeah. So I just want to know the category of the products while getting the top 5 products from our data. Okay, based upon the revenue generated for each product. Okay. So first, let us understand the data and see how we can actually get the category name before we join outside or inside. First, let us understand our data. So if you see at the higher level, there's a departments table, and there are 6 departments, and then departments have categories, and categories have products. So the relationship between categories and products is 1 to many. Okay, so I can actually join internally itself. Okay, and I can say along with product name, I can say category name here. Then sum of order item quantity, total quantity. And before adding this, let us understand the query, which let me revise where the current status. So we actually join order items and products. We got the product name, and for each product name, I got the order item, sum of order item quantity to get the revenue. Okay. In this case, my requirement is for each product, for each of these top 5 products within our dataset, I want to get the category name. Thank you, Ravindra. You reminded me. Okay, so now we'll continue where we have stopped yesterday. Yesterday we ran this query. We got top 5 products by revenue generated for that product. Now we want to extend this to get the category name. So as the relationship between categories and products is 1 to many, we can safely join categories here. So I just have to say join. So when you join the third table, once the first join clause is completed, so the first join starts with the order items here, and then join products, and then with the on condition, the first join is completed. After the first join is done, then we can actually say we can join the results with the second table, in this case categories. Okay, C on C dot category ID equal to C dot category product underscore category ID, that is the column name. Okay, and then here I can say category name, because I want to group by product name and category name to get the category name with the associated product. Okay, as product is having N-to-1 relationship, means one category can have many products. If you whether you add category in the group by or you don't have category, it doesn't matter. Okay, so here as part of the group by, I just have to say category name, and we can run this query, which will get the product name, category name, and total quantity, which is nothing but sum of order item quantity within that group. Okay, so now I am exiting from here and launching Hive. Use retail underscore DB and running this query. Okay, it is failing at, okay, I got it. Where the issue is. Here it should be limit 5, that's it. What, it didn't give any results? Why it didn't give any? It did not give any results. Let me first remove this category name from here. I know what is the problem. Let me see whether I have data in categories. From categories, limit 10. Yeah, there is data. Select star from products, limit 10. There is data. Select star from order items, limit 10. Okay. What happened to order items? I should have the data. Someone might have truncated the table. PSS-ls tabs Hive warehouse. I think someone have actually deleted my data set. DB order underscore items. There is data. Then why it is not? Okay. People are using the same path. If you see, there are some files from Mayuresh and there are some files from me. So let me see, select count of 1 from order items, describe formatted order underscore items, okay, it is under retail underscore DB. You big Raju. I think I might be in a, I think now it will work. Yeah, so I'm in a wrong database, retail underscore DB. That's why there is a problem. Now it should work. Now I'm running this query. So one more thing while it is running, see here, not all queries will run with one Mapreduce job. In this case, you can see it is saying launching job 1 out of 2. And once the first job is done, and then it is saying launching job 2 out of 2. So an Hive query might run in 0 or more Mapreduce jobs. When it runs 0 Mapreduce jobs, when you say select star from table name without any where condition with limit in some cases, you will actually get the results without running Mapreduce job. And then depending upon the complexity of the query, the number of Mapreduce jobs will be determined by the Hive engine. You will not have any control. You can tweak sometimes, but you will not have any direct control to determine to say how many Mapreduce jobs to run. It is completely taken care by Hive execution engine. It will determine. It will compile this query, and as part of the compilation, it will understand, or it will try to determine how many Mapreduce jobs it should use. So now let me add category name to the query, and let me run this query. So here we are not only getting product name for the top 5 products by revenue generated for each product, we are also including category name, so that we want to get the details about the category of the product which is being sold most. Now you got the category name for the product. Okay. So here, because it is one-to-many relationship, even if you add category name as part of that group by clause, the number of records after grouping by and doing the aggregation will not change. So we can safely join categories inside the query itself, in the inner query itself, not on the external outer query. So before getting further, I will give an exercise or task in a moment. Before giving the task, let us try to understand the output here. Okay, this is very, very important. So you can see here the query ID is this one, which is used internally. You might use it for some troubleshooting purposes. For example, the log for this query is written to this location. So if you want to see how the query have run, you can go to the location temp and D Gadiraju or Hive log directory, and then you can use this string to get into the file associated with that query, and you can see how the query ran and all. And then you can see total jobs equal to 2. As I have explained, it depends upon the complexity of the query. It will determine the number of jobs as 2. And then you can see there is a log message saying launch local task to process map join. So here we need to spend some time to understand what this map join is, and I will cover that in a moment. And we'll also see this as part of performance tuning later, but I will cover in this also, as we are in the Hive and we are talking about joins. It is very relevant for now, and you need to understand that. Okay, then there are few more things. So when it comes to join, if you have worked in traditional RDBMSs, there are different types of joins such as sort, merge, hash, etc. So typically Hive uses hash, and I will explain that when I actually talk about map join. And here, when it says execution completed successfully, that means that as part of this, there is some task which is executed, and I will explain what the task is. And here it is saying that task is completed successfully. Now actual execution starts. So as part of the first job, if you want to understand what it have done, you can go to this URL, okay, and go to the browser, and hit enter and click on configuration. Okay, and if you want to see the query which is executed as part of this session, you can say query here, and this is the query that is being run. Okay, and to understand more, you can search for something called input.dar. Okay, so I'm deleting this input.dar. No, input. Or let me search for order underscore items. Yeah, this one, input dir, not input.dir. So as part of this first iteration, it read the data from order underscore items. And here it is not showing anything related to the other two tables, products and categories. Okay, even though the join have products, categories, and order items in it, it is only showing as if it is reading from order items. So from where it actually read products and categories. So as part of this earlier stage, okay, the products and categories will be cached into the memory, and it will read from the memory directly. So the IO from the files related to products and categories is already done even before it kicked off the Mapreduce job. Hence, as it is reading from memory, it does not give paths here for the other two tables. They are already cached as cached in memory as hash map. Okay, so here while processing order items, it will look up into products and categories, the hash map results of product join of products and categories, and it will get the product name and category name out of that information. So as it is not reading from files as part of this Mapreduce job, you don't see it here. Okay, now the first Mapreduce job is done, and it all depends upon internally what it want to do as part of the first Mapreduce job, and then it will get into the second Mapreduce job. So we cannot figure out in most of the cases more 100% accuracy, but we can assume, we can make calculated assumptions about how the execution happens. So if you think about it, if you look into this query, we are joining three tables, and then we are grouping by product name and category name, and then we are doing order by. So if you recollect the Mapreduce lifecycle, which I have covered very long ago, okay, I have mentioned about shuffle and sort phase also. When I actually talk about Spark, I spoke about shuffle and sort phase. So can you recollect what all happens in shuffle and sort? On the map output, once map output will be typically key value tuples, and then before the map output is transferred into reducer as input, there is a phase called shuffle and sort. There are 3 or 4 things which will happen as part of this. So can you recollect what are those 3 or 4 phases? Unless you recollect those things, you will not be able to understand how the execution happens. You cannot make assumptions accurately. Combine is partially correct. Combine will not run all the time. There are 3 more important things which will typically run. Those are a lot more important than combine. Combine is partially correct answer. Sorting, yes. Partitioner. Okay. So the answer is it groups the data, it partitions the data, and it sorts the data based on key. When it comes to Mapreduce, it goes through all 3 phases: grouping, partitioning, and the partitioning is driven by number of reducers, and then sorting. And then if combiner can be applied, it will apply combiner. When it comes to Spark, it will only group and partition. It might not sort in many cases, but it will definitely do grouping and partitioning. But here we are running Hive queries in Mapreduce engine. As part of this, it will group the data, it will partition the data, and it will actually sort based on key. So you see, and what we do in Reducer, we typically do aggregation, right? So this is the aggregation which we need to do, and we have to group the data by product name and category name. And this grouping grouping is done as part of the shuffle and sort phase, can be done as part of the shuffle and sort phase of the first Mapreduce job, and that's what most likely happens in this query. So the join happened using the hash map. So first, even before kicking off the Mapreduce job, products and categories actually joined, and hash map is created internally. And then when the Mapreduce job kicked off, then it started reading order items data. And while reading order items data as part of the map function itself, it is doing the lookup to get the product name and category name for each order item. Okay, and then data will be partitioned by product name and category name. Most likely they will be the keys. And then aggregation, sum of order item quantity, will be done as part of the reducer. So the first Mapreduce job most likely do join between all the three tables, because we are using map side join which is default or which is enabled here. And then it actually grouped product name, grouped by product name and category name, and then it actually will do the aggregation. That will be taken care by the first Mapreduce job. Now the second Mapreduce job, what it will do, it will take the output of the first Mapreduce job and try to apply the second Mapreduce job. In this case, it will only sort the data by total quantity. It will not do anything else. Again, the number of Mapreduce jobs is driven by the complexity of the query, the number of tables you are trying to join with reduce side join, then map side join, and other transformations which you are trying to do. The main thing which you need to understand is a high query will be can be run with 0 or n number of Mapreduce jobs, and it is driven by complexity of the query. If you want to see few details for troubleshooting purposes, you have to go to the Mapreduce job. Now I am going to the second Mapreduce job, and this is the URL. Okay, and if I go here, first let us see whether we'll be able to see the query in this. You can see, okay, in this 8049. Yes, 8049, you can see the query. Okay, query is same for the same query. It is the second Mapreduce job. And then on top of that, let us see input directory. And if you see the input directory, it's nothing but a temporary directory. So it is reading the first Mapreduce job's output to process further. In this example, it will only do sorting. And can we actually confirm for sure? Yes, we can. If we reverse engineer the Hive logic and see in what scenarios how the query will be compiled in which manner, or there is another way to get those details. We can also say execution plan and use the execution plan on the query. Okay, execution plan for, I guess, or explain plan, sorry. Explain plan for. Okay, let me see. Okay, explain, just explain. Thank you, Himanshu. It's been a while, so I could not recollect immediately. Yeah, so explain is the correct one. So here it actually show based on several stages also. Okay, and so you see, this is Mapreduce. This is one Mapreduce job. This is another Mapreduce job. Okay, so these two are Mapreduce jobs. this is some local work. Even though it is claiming to be Mapreduce, it is saying local work, which is nothing but joining the categories and products locally to create the hash map out of it, and then cache into memory. And then the actual Mapreduce job kicks in, and in this, it is actually joining between order items and products. And to look up into products, it uses the hash map. Okay, and you can interpret the rest of the stuff here. And then again, there is some local work which it is trying to do, and then it has gone to the next Mapreduce. And finally, it is just fetch operator because we are using limit. This is not a Mapreduce job. So using explain plan, you can actually see what is happening in each Mapreduce job. Explain plan is just how it will compile. It will not, probably there is a way to see the execution plan also. And Hive explain plan and optimizer are not as robust as Oracle. Don't compare with Oracle. Just forget about with Oracle. So there is Oracle's optimizer is one of the best in the industry, and there we have indexes and many other things which are highly relevant for transactional based systems. Here you just to understand how the query will run, you can actually say explain, and it will not run the query. It will just compile and throw you the plan how it will be compiled and what will be done in each stage. Okay, so that's about joining the data. So now what I will do is I will give you an exercise here. So I will paste the query. So right now we are actually getting the top 5 products in the entire data set. Okay, so instead of getting top 5 product in the entire data set, I want to 1 minute. I don't want to give that exercise. It will be complicated for you. Let me think of some other task real quick. Yeah. So the next task will be, I just want to get. So right now, what we are getting, we are computing revenue for each product on the entire data set. Okay. So the next problem statement or task, I will give 10 minutes to write the query, and the requirement is, I want to get information by date. So for each day, I just want to see the product name, category name, and sum of and the revenue generated for each product. Sorry, let me type it here. So the task is get category and revenue for each category for each day. Okay, so this is the task. So I will give some hints here. So category, actually I need category underscore name, and revenue is nothing but aggregated field. Okay, so I get category name and revenue for each category and for each day. So the output should be date or order date, category name, and the revenue. You can give it as daily revenue, whatever field whatever name you want to give, and it should be sorted by order date and then daily revenue in descending order. So here category name can be fetched from categories table, Revenue is derived from order item subtotal, and day or date is actually fetched from orders. So you have to join four tables: orders, order items, products and categories, and then get this output. So it's a simple task. It is not exercise. I will give a little bit more complex exercise little later. So write a query. I will give 10 minutes time. So it's 12:17 now. We will wait until 12:27. If you have any questions at any point in time, please raise those things. And if you are done with the query, you can paste the query to me. I can validate the query by running in my database also. So this is the query which you can use as template. That's why I mentioned to create Hive tables earlier. So if you did not create Hive tables, then you will not be able to write these queries in quick uh, write these queries quickly. So at least now you just make sure you are up to speed, because we'll be writing a lot more complex queries. I will be covering analytical queries, and there will be good exercises which can improve your SQL skills in general. So make sure you are up to speed, have the databases so that you can practice all these things. So revenue is derived from order item subtotal. Order items dot order item subtotal. Did it work? I thought it will not work. This is not ANSI SQL. So let me see. Okay. So they fixed this also. Earlier it used to not to work. Yeah. Good to know. Earlier it used to support only ANSI SQL. Now they have changed. See, all these changes they made to reduce the differences between traditional RDBMSs so that people can easily migrate.
So ANSI SQL means
ANSI SQL.
whatever I wrote or
No, whatever you wrote is not ANSI SQL. It is typically Oracle type of join. ANSI SQL is using.
ANSI SQL is like join on
Yeah.
column and all.
Yeah. Yes. That is ANSI. So it seems many people are running. So mine is still waiting for the resources. So if your query is stuck, what you have to do, you have to go to Resource Manager with 8088 as port number, rm01.itversion.com, colon 8088. And here, no, everything is done. Then why it is taking so much of time? Interesting. So for you, did it take a long time or did you get results immediately, Ravindra?
I got it in 27 seconds.
Okay, I don't know, for some reason. Okay, mine is hung actually.
Actually, 85364.
Yeah. No, mine is hung. That's why it got stuck. For some reason, it. No. It got hung for whatever reason. Yeah, I just killed it and I'm logging back again. So you missed order by. You have to use order by also so that you get the data in data sorted by order date and then by revenue in descending order. So you missed this portion. I don't know why it is being hung.
Actually, Durga, I am executing on my my schema. Ravindra underscore.
That's fine. But still, if there is any issue, it should complain or it should come out. It should not hang like this, right? So let us see.
Now also, yeah, I think again 27 seconds. I got the
Okay.
data again. Yeah. After I adding the order by.
Okay. Okay. So let me see where it is actually getting stuck. Ravindra underscore final, right? So let me run it here.
No. Ravindra underscore retail underscore DB. Even you can use Ravindra underscore final.
Yeah. So there's seems to be there is some issue. Okay. I think I don't have data in orders. Probably it could be a bug. Because in my database I don't have data in orders, it might be stuck. That could be the reason. Okay. So it seems to be good. So the way you can validate is there are 364 days, and there are around 60 products or something. So 364 into 60. But 60, you might not have transactions on all the products every day. So that's why you got 8,536 records. If there are transactions on all the products, probably you will get 18,000 records. So by doing some sanity check, I can confirm that the output looks fine. Okay, so now we will expand further. Okay, instead of getting data sorted by order date and then daily revenue in descending order, now we would like to get top 5 products by revenue. Okay, for each day. Within each category, I just want to get 5 top 5. Sorry, let me put this way. For each date, I just want to get top 5 categories. I think there are around in this case it's categories, not products. I was wrong. So there's around 60 categories. Out of these 60 categories, I want to get what are the top 5 categories on each and every day. Okay, and here comes the concept of windowing functions. So I will write the query real quick, but I will start explaining as part of the next class. So I'm taking the same query which is developed by Ravindra. Okay, so here we are joining these 4 tables, which will get the revenue for each date and for each category. Okay, now I want to get top 5 products. That the very legacy, the very old way or legacy way, which no one is using these days, is to write a very complex self-join query. You might have to join recursively multiple times, and then you can get top 5 or top n products, top n categories for each date. In this case, we are talking about categories for each date. So the very old way of doing it is very crude and not efficient also. So in last, I think around a decade back, Oracle have introduced a concept called Oracle Analytic Functions. And now almost all the databases have that. In Oracle, it is called as analytic functions. In other databases, it is called as windowing functions. So if you hear these two terms, they are similar depending upon the context you are using. If it is Oracle, they call it as analytic functions. In case of any other RDBMS, most likely they are called as windowing functions. In Hive also, they are called as windowing functions. And before implementing the actual logic here, now let us understand what the windowing functions is all about. Okay, so I'm taking our earlier query where we have only product name and order quantity. So let me take this. Let me take this query. And so what this query will give for each category and product. We want to get the revenue. So this will give that. Now within each category, I want to get top 5 products. Okay. So this one will give within each category what is the amount of revenue generated by each product. So what we have to do using this. So this will be the results which will contain the category name, product name, and order item. Sorry, revenue for each category and product. Using this information, how can we further process? We can actually use this entire query as inner query. Okay, so this will make it as inner query, and we have to give alias in Hive. It's mandatory. So Q is the alias, and this star represents the category name, product name, and total quantity. So what is our requirement? Within each category, I want to get top 5 products by revenue. Okay. So I want to display all the 3 fields. So I'm giving category name, product name, and then total quantity. These are the 3 fields. Okay. But within this data, I want to apply the rank function. And the rank function should give ranking of 1 to 5 within this category name and product name, sorting by total quantity in descending order. So that person has to be implemented using windowing functions. And how it will look like? So there are several analytical or windowing functions. We will see few of those. One of them is dense rank or rank. We can use rank to begin with. Okay, and if you want to get the details, you can, I think, run show functions here. Let us see there is rank here or not. There is a rank here, and you can say describe function rank. Okay, there is no documentation for function rank, so probably you might have to go to Hive user guide, and you might have to search for it. Okay, so this is the problem with open source rank, and then I want to partition the data, and within that partition I want to give the rank, or I want to group the data, and within that group I want to give the rank. So we have to use keyword called over. This will begin our analytical function. Okay, over, and over has to follow with the circular brackets. In this, first we have to tell how you want to partition. Okay, so sometimes we might not even want to partition. For example, within this data itself, in the same way as we got the limit 5 will give only the sparse rank, the top products from the entire data set. If there are collisions, means if there are more than one record, even when it comes to global ranking, we cannot use limit directly. Okay, we still have to go with rank. So let's try to understand how we can use that. So here what we have to do, we just have to say partition by 1. So we are just saying, we are hard coding with some value so that it is partitioned globally. And then how we want to sort the data? We want to sort the data by total quantity in descending order. So order by total quantity in descending. So only when it comes to ranking, we have to use partition and order by. There are other functions also, in which case order by is not required. We will see few more scenarios. Okay, in this case I am starting with global ranking itself. Instead of getting just top 5 products, I want to get all the products which falls in the top 5 range. If there are multiple products which generate the same amount of revenue, exactly same amount of revenue, I want to display all those things if they fall in top 5 rank. So this is how we can use. So rank will give sparse rank. If you want to do dense rank, you just have to say dense underscore rank. Now, once you did this, okay, you have to give alias for this RNK, and then you have to say select star from. Again, we have to typically the analytical function query will become a inner query, and there will be a external query if you want to apply where condition on top of it. In this case, I just want to get top 5 products by revenue. Even if there are collisions, which is dense rank, I want to get all the products. Okay, Q, and then where RNK less than or equal to 5. Okay, so what this query will give here, we'll get only 5 values, but if there are multiple products which are generating same amount of revenue within the top 5 products, we will 1 minute. What happened? Here I have to give name. We'll get all the products. Now you can see it is running. So this is also global ranking, but we are trying to simulate the dense ranking. Okay, with limit we cannot get dense rank. We can get only the top 5 products, and if there are 5 products which are generating same amount of revenue, you will see only those 5 products. Even though within top 5 revenues there are multiple products, more than 5, you will get only 5 with the limit, the way we have executed yesterday. If you want to simulate dense rank, you might have to use these windowing aggregate functions to implement that logic. So the way you can partition the entire data set into one group is by hard coding with some literal. In this case, I just used 1. Partition by 1 will make everything as one group. Within that, I am sorting the data by total quantity in descending order, and then computing, giving name as RNK for this computed field, and then using this RNK as part of the where condition to get the top 5 products. And you can see here, we are also displaying the rank for this. Okay, and now if I want to actually do so that's what it's hard coded. The entire data set will be partitioned as one group. There is no field here because I am trying to get the global ranking. We have to consider entire data set as one unit. Now I want to improvise further on this, and I want to get top 5 products applying dense rank within each category. So which field I should use here? I want to get top 5 products within each category applying the dense rank. So which field should I use here? Should I use category name? Should I use product name? Or should I use both? So the question is, I want to get top 5 products within each category. That's correct. Himanshu said category name. And then this order by total quantity will not change because we are trying to compute rank based on total quantity in descending order. So this will not change. And if you run this query now, So you can see within each category, you got the top 5 products based on the revenue. Okay. For cardio equipment, I think there are only 2 products. We have to validate this data. It might be correct, it might be incorrect, but we have to validate. For fishing field and stream sportman, 16 gunfire safe. Sorry, in this case, I think this is category and this might be the product, and probably there might be only one product. Okay, so you can see the results now. We got 88 rows. First, let us see, select count of one from categories. So there are 58, and we can also say select category name, comma, count of one, category, product category ID. I'm just validating that my results are correct. Product category ID, comma, count of one from products group by product category ID. Hit enter. And windowing functions is part of syllabus in CCA data analyst certification, and everyone should know the windowing functions. It's not only elegant in developing the logic, but it is very powerful also. It's very, very efficient. So most of them have 24 products, but probably there might not be enough transactions. So I have to dig this further to validate, but I think this is working. Okay, now you get the revenue for each product, and also we try to get the top 5 products within each category. Okay, so this is the query using analytical functions. We have used dense rank function over in the partition by within which group you want to apply whatever analytical function you want to use, and then if required, especially for functions such as rank, dense rank, etc., you can apply order by condition so that you get the data in ascending order or descending order, and then compute the rank using that. If you just want to get revenue, okay, sometimes I will explain as part of the next class, but sometimes what we want, typically when we use group by, so in this case, right, so if I go back to this query, there is a limitation. What is the limitation? If you just want to get category name, if you use group by, you as part of the select clause, you can only get aggregate functions, and then you can get category name, product name, which is used in group by clause. But if you want to get all the details about the category on top of category name, you will not be able to do that using this approach. Even in that scenario, we have to use analytical functions. So if you look at this query is only giving us category name and product name on top of order revenue. But sometimes we might want to get all the details from category name, okay, or even from product name, or even from orders. Then we might want to do some advanced processing on top of that data. In all those scenarios where you want additional fields which are not grouped to get this aggregated revenue, in that case also we use the windowing or aggregate functions, which is typically the function name over, and then as part of the brackets, either we will use partition by clause or order by clause, or we can actually use everything also. So here in some so earlier when I did the global ranking, I said partition by 1 and then order by total quantity. Some databases If you want to use order by, this partition by is mandatory. That's why I have to say partition by 1. In some cases, it is not mandatory. So if it is not mandatory, you can delete this also, and you can just use order by, and you can get the top n products just by using order by without using partition by. So you can use this function in Hive. But in some databases, you might have to use partition by before if you have to use order by later in computing the rank. So if you have to do that, you just have to hard code the value like partition by 1 or something, so that everything will be grouped as one data set on which the windowing functions can be applied. Okay, so we'll see a few more examples. It's very, very powerful, and in general also it is very important from even for traditional RDBMSs. So I will give you an example. Using these windowing functions, I have rewritten the project, and the queries which used to take several minutes are used to return results within 10 to 15 seconds. They used to take several minutes, and the query is also very big and it's clumsy, and in the end I rewrote most of the queries using windowing functions. And once we started using windowing functions with a little bit of other performance tuning techniques in Oracle, the results came down to 10 seconds to 15 seconds. The queries started returning within 10 seconds, 15 seconds range. So very, very powerful. Probably if you're from Oracle background, if you have used it, you will know that. I will conduct a Oracle workshop in next few months, especially performance tuning workshop, and there I will try to demonstrate how powerful it is, and I will try to get into internals also. Okay, so now let me see this question. Okay, last query. This is for global ranking, global depth ranking, and this is for other purpose, where we want to get top 5 products within each category. Okay, that being said, thank you very much for joining the session. We'll catch up on Monday. We'll continue on Hive as part of the second part of this workshop. With next week, we will be wrapping up Hive also, and we'll be wrapping up Spark, and we'll get into other topics. I can take questions, means I will wait 15 seconds. If you have any question, you can raise it. If you don't have, we will conclude and we'll catch up on Monday. Tomorrow is Saturday, right? No classes on Saturday. Only on. Yeah. Today we have class at 2:30 p.m. and I think I sent you the invitation. It says 4 a.m. but that 4 a.m. is US Eastern time, which is 2:30 p.m. our time. So that session is there because I took 2 days break. I want to catch up, so I am conducting session today. So Himanshu is the person who is from Tawant but little bit late in attending these classes. So he is attending afternoon session which I'm taking for others. So he just want to make sure that we have session today afternoon. Okay then, thank you very much, and we'll catch up on Monday. Bye. And those who are on YouTube live, thank you very much for joining the session, and we will continue on Hive. And if you have any questions at any point in time, just start using discuss.itversity.com. For lab, you have labs.itversity.com, and we will be glad to help you in case you run into any issues while practicing the tasks which are being given as part of these sessions. Even though I could not take your questions live, we'll try to support you offline using the forums. That being said, if you like the content of these videos, please click on like. Okay, so here it is. And if you want to share with your friends, you can share. And that being said, thank you. Bye.